Hello everybody, welcome back to another session in HPSG. In this video we are going to look at how the lexicon is structured. From the beginning we have been reducing the number of rules in grammars. While reducing the number of rules in grammars, we have been burdening the lexicon with lot of descriptive information. The lexicon contains lexical entries which are basically phonological forms, and along with the phonological forms we have been giving feature structure descriptions. If you remember, each lexical item looked like this: the word, the phonological form, along with the syntactic information and semantic information. All the information is given in the lexical item, that is including the what agreement it takes and what specifies it takes, what kind of complements it takes. All the descriptive information is given in the lexicon. So the lexicon should have very good internal organization. We do not want all information to be not simply listed. If we simply list all the information in the lexicon, then the lexicon will be too heavy and too huge, which cannot be managed. So we need more generalizations even within the lexicon, and whatever lexical information we want, that should be predicted too. So in order to do that, we need to look at how the lexicon should be structured. We have already introduced a hierarchy of types, and we have introduced the types in order to define appropriate features for each lexical item, and we also introduce the types to avoid to specify values for features that are irrelevant to particular classes. For example, if you have a class of nouns have certain types of features which verbs do not have. So the features which are irrelevant for nouns are not given for nouns. Similarly, the features which are irrelevant for verbs are not given for verbs. So types were introduced to define feature appropriateness, and we try to specify values which are necessary for that particular class. We have also used constraints on each type, that is, each feature structure also contained certain constraints. For example, we have used a nouns AGR specification with the AGR specification of the element on its specifier list. That is, the head value will contain agreement feature which matches with the specifier value. That is, if the head noun is singular, we also need a singular specifier with it. So that kind of constraints are also included in the types. And we also included subtypes, that is, types contain subtypes of others, where every feature specified for a subtype is also appropriate for its subtype, or every constraint which is given for a type is also specified or appropriate for subtype. That is, whatever constraint which a type obeys, the subtype should also obey. This is the model which we have adopted till now. But alternatively, we have something else. Let's say all the constraints inherited by a subtype are default. Okay, by default all constraints would be inherited by a subtype, and any contradictory information on the subtype should take precedence over the default information. Okay, earlier what we said, whatever constraint is on the type, that is inherited by subtype, but we didn't say the subtype will have some contradictory information. No, what we are looking at is each type has default constraints, and subtypes may have some contradictory information which may take precedence over the default information. For instance, a constraint associated with a lexical type TI. You have a TI lexical type which has a constraint which is marked as default. Then the constraint holds of any lexical entry of type ti for which it is not explicitly overridden. So any lexical entry which is of type ti will have to obey the constraint given on type ti because that is default. But this default constraint can be overridden in one of the two ways which are given below. First, by a constraint associated with a subtype that contradicts the default. So ti is a type, it may have a subtype. If that subtype has a contradictory constraint, then that will override the default constraint. Secondly, if the information stipulated on a particular lexical entry contradicts the default, not the constraint but information, we are talking about information on the lexical entry contradicts the default constraint, then also the default constraint may be overridden. That is, a particular instance of a maximal type tj, that is tj is a subtype of ti, could contradict the default. This is the model now. That is, what we are saying is there are types, there are subtypes, and each type has a default constraint or default information, and that constraint or default information may be contradicted or taken precedence over by a subtype. Subtypes, if the subtype has a contradictory constraint or if the subtype has contradictory information. This model which we are proposing is very natural. It is there in all the natural languages. Natural languages also show this kind of hierarchy, what we are proposing. How is it? Nominal specifier agreement. Remember nominal specifier agreement which we have seen, that is noun and which will have a specifier and there should be agreement between them. That is a nominal specifier agreement, which is motivated by all common nouns, right? That is, if you take a word like dog, which is a common noun, the word dog needs a specifier. The specifier has to be determiner, and that specifier has to be third person singular, right? The specifier has to be singular. So how do you, that is the nominal specifier agreement. So in the specifier of dog, we say that it has to have specifier, and in the head feature we say that agreement value of the word dog is singular and they two match. So that was the nominal specifier agreement. But look at nouns, other nouns. This is a common noun. Look at other nouns like proper nouns. Proper nouns do not need an SA because they never take specifiers. But remember, they are third person singular, like dog. Dog is a third person singular. Proper noun is also third person singular. But proper nouns are different from common nouns in the sense that they do not take any specifiers. So how do we account for proper nouns? We can account for them by introducing a constraint that the value of AGR must be of type 3 or third singular, and the argument structure for proper nouns must be empty. What is the argument structure? Specifier and comps, right? Remember argument structure which we have used, arg struct, as a separate feature along with syntax and semantics, right? So argument structure must be empty. If you put this constraint, then proper nouns are defined differently from common nouns. But we find exceptions to this constraint which we have used for proper nouns. That is, we have names of many mountain ranges which have a determiner and they appear in plural. For example, you say the Himalayas. The Himalayas is the proper noun, the is the determiner, and Himalayas is in plural form. So how do you do that, right? So this supports the default hierarchy view. The default hierarchy view says types have constraints and there are subtypes which may have contradictory information which will take precedence over the types information or default information or default constraint. Let's represent this diagrammatically. Overall conception of lexicon is as shown in the figure. Let's say this is how we are going to have the lexicon concept, where lex item is a lexical item. So lex item is short form, which will have all the lexical items, which will have all the types of lexical items. And each lexical item belongs to a maximal type, TM. TM is a maximal type, and lexical item belongs to TM. And maximal type consists of subtypes, which are TI, which are intermediate between lexical items and maximal types. So maximal type TM, intermediate elements we have subtypes TI, and you have lexical items. Lexical items contain all types of lexical items. And each type in the lexical hierarchy has constraint with it. Some are inviolable and others are default in nature. So each lexical item inherits constraints associated with the maximal type and also subtypes which the maximal type contains. Right? Each lexical item inherits all the constraints from TM and also from TI. Let's look at the lexical hierarchy. So lexical item consists of two subtypes. Each lexical item consists of two subtypes. What are the subtypes? Word and lexeme. What are words and what are lexemes? Lexeme is an abstract proto-word and word is the relation of it. Okay, words are derived from lexemes with the help of lexical rules. Okay, what do you mean by these? When I say word, we commonly understand anything which is pronounced, which is together, which has a meaning. So if you take word like kill, kills, killing, killed, right? There are 4 forms. They're all words. If you ask any common man, they say they are all words, right? And we also feel that they are words. But we understand that all of them have a kind of meaning. There is some action of killing, right? That is abstract. That is abstract. So that we call lexeme. If you are writing word and lexeme, we may write all the words in small letters, right? And we can write the word lexeme in capital letter, possibly, in order to make a distinction between word and lexeme. So words are realizations. They are derived from a lexeme. So if you have a lexeme, kill, from that you derive a word, kills, that is third person singular. And then you can also have killing, which is a present participle form of the lexeme, kill. Right? That's the distinction between we make word and lexeme. We will look at lexical rules later, but till then remember that words are derived from lexemes with the help of lexical rules. That means what we are doing is, earlier we mentioned all the words in the lexicon. Till now what we are doing is we mentioned all the words in the lexicon, right? Giving each detail. Like if you have a verb like kills, we'll say the verb kills will have third person singular, and right, it needs a specifier, it needs a comms, etc. But now what we are doing is kills is derived from the word kill, and kill will not have an AGR, right? So we need to derive a word from a lexeme. So that's what we're going to do by using lexical rules. And constraints specified on lexical item also applied for word and lexeme. So lexical item is a type. It will have 2 subtypes, word and lexeme. So if you have any constraint on lexical item, that will have to apply also for word and lexeme. So we introduced argument structure. Let's say argument structure is a feature of lexical item. So all lexical items will have a feature argument structure. But when it comes to word and lexeme, they inherit the argument structure. They inherit the feature argument structure from lexical item. And whatever constraint we fix on the argument structure will also apply for word and lexeme. So if the word has a contradictory information against the argument structure, then that will take precedence over argument structure which the lexical item has. Lexemes have two further subtypes, right? Lexemes can be inflected and not inflected. Why are we saying if you take a verb like kill or love or dance, they can also be inflected. That means you can get an inflection on them. But if you look at words like to, in, that is prepositions, or conjunctions like and, or, they are not inflected, right? So we find two types of lexemes. What are the two types of lexemes? Inflecting lexeme, and constant lexeme. So we call those lexemes which are inflected, we call them inflecting lexeme. Those which cannot inflect, we call them constant lexeme. That means they do not change, the form do not change. So this is the hierarchy we are finding now. A lexical item will have a lexeme and word as subtypes, and a lexeme will have inflecting lexeme and constant lexeme. So lexical item will have argument structure which will be inherited by both and by these two also. We also have now a particular feature by default. All lexemes will have mode value none by default. All lexemes have mode value none by default. This is the constraint. The constraint is now lexeme with semantics mode value none. If we say mode value of lexemes is none, then inflecting lexemes and constant lexemes will also have mode value none. But whatever subtypes we will get in these may have some contradictory information. Like if a verb will be a subtype of inflecting lexeme. Verbs will have proposition as their mode value. Then that will take precedence over this. Okay. So what we have seen in this video is that we tried to burden the lexicon earlier, but now we are trying to reduce the burden by looking at the structure of the lexicon. We are using the lexical hierarchy, type hierarchy. So containing types containing subtypes, subtypes containing subtypes. And earlier we said only subtypes can inherit the features from types, but now we are saying no, not necessary. Types will have default information and subtypes may have contradictory information which may take precedence over the default information. And this concept is very natural. It is found in natural languages. We have seen already this in nouns. And what we say about the structure of lexicon is each lexical item belongs to a type which is maximal in nature, and there will be subtypes of that maximal type, and all the types will have default constraints, and they may have inviolable constraints or some have default constraints, and lexical items may have some information which may contradict the default information. We have now detailing our lexicon, where we say the lexical items contain two subtypes, word and lexeme, Word is a realization of lexeme, and we have argument structure as a feature of lexical item. So both words and lexemes will have argument structure. And when we look at lexemes will have two subtypes. Lexemes can be either inflecting or constant lexemes. And what is a lexeme? A lexeme is something which has semantic mode none. See you in the next video.